AI has a heat problem because it is scaling faster than the infrastructure built to cool it, and the result is a materials and engineering problem. Every GPU inference cycle generates heat, and at the scale of modern AI data centers, that heat becomes an infrastructure problem. Cooling already accounts for 45 to 50% of total energy consumption in AI data centers, making thermal management as strategically significant as compute itself. Air cooling, the industry default for decades, is hitting its physical limit. Rack densities driven by NVIDIA's Blackwell GPUs are simply too high for air to dissipate effectively. The majority of new U.S. AI data centers are being built on drought-affected land. Between now and 2030, AI servers could consume over 1 trillion cubic meters of water annually. In the Gulf, Saudi Arabia, the UAE, projections reach 426 billion liters per year by 2030, in two of the most water-stressed countries on Earth. This week, NVIDIA announced a new cooling system designed to address water concerns. It's a meaningful step. But reducing water use at the chip level is not the same as fixing AI's water problem at the infrastructure level. Total demand keeps rising as workloads scale. Efficiency alone cannot offset growth indefinitely. Meanwhile, the cooling industry faces a supply chain shock. 3M, maker of Novec, the dominant fluid in two-phase immersion cooling, exited PFAS manufacturing entirely at the end of 2025, citing a $12.5 billion liability settlement. The most efficient cooling fluid for high-density AI racks just disappeared from the market. 3 technology categories are now racing to fill the gap: single-phase immersion cooling, direct liquid cooling, novel fluid alternatives. This week, Trinity Biotech launched Trinovium, a healthcare-grade fluid targeting the data center market. The liquid cooling market is projected to reach $29 billion by 2033. The question is not whether liquid cooling wins. It is which materials and which companies capture the margin. Europe is already turning the problem into an asset. Google's Hamina data center supplies 80% of local district heat demand. Microsoft is warming 6,000 homes in Denmark. AWS covers 92% of a Dublin campus's heating needs. Waste heat recovery is converting a liability into a revenue stream, and regulators on both sides of the Atlantic are beginning to require it. The investable stack is forming across 4 categories: heat transfer and liquid cooling infrastructure, PFAS alternative fluid suppliers, waste heat recovery, and water technology, the sleeper category. The companies solving AI's heat problem are not household names yet. That is the opportunity. The map is not the territory, but the heat is very real. That's it for this week. Thanks for watching. Until next week, more details and sources in the newsletter.